Okay, so before we start talking about sample sizes, let's just go back to where we left off last time. So last time we left off right here, and I had told you to self-test yourself with these 4 true and false questions about interpreting confidence intervals. So there's really only 2 of these statements that are ever going to be true. First, number 3 is true. And we know that number 3 is true because of what the central limit theorem tells us about the normal distribution of sample means and proportions. And number 3 is the reason that we can say number 1. And this is the definition of confidence intervals. And beyond that, there's a lot of ways to string these words together: probability, confidence, parameter, statistic, in construct sentences that are grammatically correct, but that are not statistically correct. So number 2, for example, talks about, it says there's a 95% probability that a specific 95% confidence interval contains the true percentage. Okay, so this word right here, it's a picky thing, but this is what we're talking about in detail on the previous slides. To talk about a probability in association with a true percentage would be implying that the true percentage changes, okay, that it has variability, okay. True percentage is one number that does not change, and therefore there's no probabilities that can be associated with it. So that is a false statement. Okay. And the number 4 says there's a 95% probability that the statistic is in the 95% confidence interval. Okay, now, and the statistic does change from sample to sample. However, the statistic is always in the interval. The statistic is at the center of the interval. When finding confidence intervals for percentages, p hat is our statistic, and it's at the center, going out in either direction, margin of error. For example, suppose you have a confidence interval of 0.25 to 0.39. What is the sample percentage, which is our statistic? So p hat, sample percentage, is at the center of this interval. And how do we find the center? We can do that just by taking the average of the 2 numbers. So the average of 0.25 and 0.39 is 0.32, which is our sample percentage. So that tells us we have an interval with 0.32 in the center and endpoints 0.25 and 0.39. So the next question is, what is the margin of error? So what number did we add to 0.32 to get 0.39? So, well, we can, by subtraction, we can find out that, well, we must have added 0.07. Or we can go on the other side. What number would we have to subtract from 0.32 to get to 0.35? And we would also find 0.07. So the margin of error is 0.07. And so if we have an interval and all we have is the interval, okay, we can tell from that what the sample percentage is and what the margin of error is. So our next example comes from this study that was done back in 1992 as a joint study between IBM and Johns Hopkins University. And in this study, they found that among 30 women who worked with chemicals at 2 IBM plants, so they were working in the manufacturing of computer chips, and then became pregnant. 10 had miscarriages, which is a miscarriage rate of 33%. So if we want to find a confidence interval for that miscarriage rate, our givens are n equals 30 and p hat equals 0.33. So our givens in this IBM Johns Hopkins example are n equals 10, p hat equals 0.33, and let's suppose that we want to find a 90% confidence interval for the true percentage of pregnant women that miscarry if working with these chemicals. A confidence level of 90% tells us that Z star will equal 1.645, which we get if we put 90% in the middle. We've looked that one up several times. So putting that all together, our confidence interval will be 0.33 plus and minus 1.645 times our standard error expression. So look at this margin of error of 0.14, 14%. We've never seen a margin of error that large in any of our examples. So that we have this huge margin of error because we have very small sample size of 10. Now suppose that they're going to plan a follow-up study. And this is very typically how studies are done, that they start with a very small sample to work out all the protocol, and then they use that smaller sample to plan a larger sample. So let's suppose in their future study, they would like to get a margin of error of only 7% instead of 14%. The question is, what sample size would they need to achieve a margin of error of 7% with 90% confidence? So using preliminary results of p hat equals 0.33 gives us this expression for the margin of error, and we want to find an n sample size that gives us a margin of error of 0.07. So first of all, squaring both sides to get rid of that square root sign, and then cross multiplying gives us this. And so that gives us 122.1. And so I don't know, what is that? Like, what's 10% of a pregnant woman, like an arm possibly? Okay, so yeah, we can't just take an arm. If we want any part of that pregnant woman, we have to take the whole pregnant woman. So which means that we need to take a sample of 123. So when finding sample sizes, you always round up. what the decimal is, you have to round up. Okay, so we don't have to do all that algebra every time. We can do that algebra in general and create a new formula. So here's the expression for our margin of error. Okay. I purposely did not put p hat in there, just put p in there, and I'll come back to that in a second. So we square both sides and then cross multiply, which gives us this expression. And now what about these p's? We don't know the population proportion. That's what we want to estimate. We don't know p hat because we haven't taken the sample yet. So we're going to call this p star. Okay. For now, we'll come back to that on the next slide. And I also am going to add one more thing on here, which is like this shoebox top looking thing. And that's called a ceiling function, and that means always round up. So now here on page 136, okay, here's the formula from the previous page, and let me make a note on this. Okay, that means always round up. Okay, so we have two choices for p star. Okay, one choice is to use some prior estimate, like if you have a pilot study and you get, for example, that we used in our previous example, they had a pilot study where they had a p hat of 0.33. So they used that for estimating the sample size on a future study. Well, what if you don't have any prior information? If you have no prior information, your best guess is 50-50, i.e. 50% or p star equals 0.5, okay, which is what the second choice here says. So let's look at what we would have gotten in the previous example if we had used p star equals 0.5 instead of 0.33. So to find a sample size for 7% margin of error with 90% confidence, using p star equals 0.5 gives us 1.645 squared times 0.5 times 1 minus 0.5 divided by 0.07 squared, and put our ceiling function on there. And if we plug all that in the calculator, that's going to equal 138.06. And we want to round that up, which means we need a sample size of 139. So note that this is larger than the n equals 123 we got using p star equals 0.33. So using p star equals 0.5 always produces the largest sample size. And that's why p equals 0.5 or p star equals 0.5 is the safe guess. Okay, because if you use the largest sample size, you're going to have all your bases covered. So in the last class, I told you to do 16A as a pre-assignment for this section. And when you made the graph on 16A, which was a graph of the proportion versus the standard error that you got with that proportion, and what you should see on that graph is a parabola, okay, where the highest point here is at 0.5. So P equals 0.5 gives the largest standard error, okay, which means it's also going to produce the largest margin of error, which is Z star times the standard error. And that's what tells us that we're going to need a larger sample size. Okay, well, or actually the largest sample size, I should have probably said. So yes, largest sample size. Okay, so one more example before we wrap this up. And this is from the same social media study that the Twitter example came from. And they reported that 20% of Americans often get their news from social media. And you want to plan a new study which will have a margin of error of 3% with 95% confidence. So givens are margin of error equals 0.03 for 3%. Make sure you do 0.03, not 0.3. And if we want to use prior data, we could use a P star of 0.2 for 20%. And a confidence level of 95% tells us we should use a Z star of 1.96, our old favorite. So plugging all that into the formula on page 136 gives us 1.96 squared times 0.2 times 1 minus 0.2 divided by 0.03 squared, which equals 682.95. Rounded up means you'd need a sample size of 683. But now let's suppose that you say, well, hey, this is just, we're in a different world now than we were in 2018. People are all sheltering in place, and so you don't think it's really appropriate to use the estimate from more normal situation. So you say, well, I think I want to be safe, and if I want to be safe, then I'm going to use P star equals 0.5. So this will give us a sample size of 1.96 squared times 0.5 times 1 minus 0.5, which is 0.5 obviously, divided by 0.03 squared, and that's going to give us 1067.11, which will round up to 1068. So notice how much larger this is. With P star equals 0.5. And in all honesty, typically 0.5 is what's used because people want to be safe, unless it's really a matter of a larger sample costing a lot more money. Okay, so if a larger sample is going to have a lot more cost to it, people might go with a lower one. But generally, like surveys and news organizations always go with the larger one. And also, typically they always use 95%. So one last note here, just to stress that this is the sample size if you can choose a random sample from the population. Okay. And this used to be much easier back when pretty much every household had a landline and they could randomly select numbers that way. And now it's much harder to achieve a random sample. So we're seeing, like we talked about earlier, Gallup poll, for example, taking much larger samples than would have been indicated by this. They used to always take samples right around like this 1068 number to achieve their margin of error of 3%. So at this point, you should pause the video and do in class exercise number 16.